Well, we're going to play with the metric system today. But first, before we get to that, I want to show you something back related to last lesson when we were playing around with these engineering prefixes. Remember, we had this idea that if you had 10 to the 12th, in other words, a trillion of something, if you had a trillion watts, say, you could call it 1 terawatt. A trillion watts is 1 terawatt, and so on. So you had all of these different engineering prefixes, and if you didn't do the last lesson, please go back and do it, because I'm not going to re-explain it all right here. But I do want to show you something that I'm not sure I showed you in the last lecture. Look at this thing. You got 1.25 megavolts. You want to convert it to kilovolts. How can you do that on your calculator? Well, you could do it like this. So you might remember that the way we entered megavolts on our calculator last time is we used that times 10 to the x button, which is bottom center on my Casio here. So I'd hit the 1.25, and then I'd hit the times 10 to the x button, and then it's waiting for an exponent. Don't hit the button that says raised to a power. Just hit the number. What's the exponent? And it's mega, so you can cross-reference if you don't have it memorized yet. Mega is 10 to the 6th, and so you put the 10 to the 6th there, and then all I'm doing is entering the number on my calculator, so I hit the equals, and what does my calculator say? Right now, come on you, right, come on you, okay. Right now my calculator says this, 125 with 4 zeros. And if I hit the eng button to put it in engineering notation, it says 1.25 times 10 to the 6th, which of course is what we started with. So how does that help me get to kilovolts? Well, the secret is hit the eng button again. Where is it? Where'd it go? Okay, bam. And now it says 1250 times 10 to the 3, which I hope you recognize 10 to the 3 is what kilo means. And so since our whole goal was to convert to kilovolts, there's the answer, 1250. Dum, da, dum, dum, dum. Ain't that cool? And of course you could hit the eng button again. If I hit the eng button again, now it's saying 125 with 4 zeros times 10 to the 0, which is the same as this number, right? 10 to the 0 is 1. So it's 100, what is that? 1,250,000, right? And you can hit the eng button again and again and again. And if you want to slide the other way, you go shift eng, shift eng. And if you go shift eng enough times, you'll get back to 1.25 times 10 to the 6th. And if you go shift eng again, you'll get 0.00125 times 10 to the 9th, and so on. So anyway, using the eng button repeatedly, or shift eng repeatedly, you can actually slide back and forth among the units on this table. So it's really, really cool. Now I just wanted to show you that. Actually, in this lesson, what I'm going to do is I'm going to do things by hand, which is kind of like saying in your head, except you have to do it by hand first before you can do it in your head, right? That's true for me anyway. So if you do this by hand, what would you do? You start over. 1.25 megavolts equals, I'm trying to get to kilovolts. You use this as a sort of a street map. That's an arrow. You use this as a street map. Start at mega house. I'm at mega house. I'm trying to get to kilo house, which is over here. So notice I'm trying to go to the right, and I'm going over to the next house over. Now the thing is, these houses are separated by 3 steps, you might say, or 3 whatevers. Because that's a 6 and the exponent's coming down by 3, it's kind of like 3 steps, right? 10 to the 6th, 10 to the 5th, 10 to the 4th, 10 to the 3rd. Okay, so that's it. Move your decimal 3 places to the right. So that's what I kind of did, right? 1, 2, and then you have to pad another 0 in there. 1250 kilovolts. Now ain't that something? That was faster than pushing buttons, for goodness sakes. So if you have this table more or less memorized, or at least handy, then that's all you've really got to do is slide. If you're going between any of these 2 units, you can just use it to figure out how many decimals places to slide. So let's do that on this one, because we're going to be doing that for the rest of the lesson, really. We're going to do it by hand like this. So here, what have I got? I've got mega. Start at mega's house. I'm at mega's house. Where do you want to go? I want to go to tera. Tera, that's way over here. So you're going to the left. Notice, start at mega, and it's 3 jumps to get to giga, 3 jumps of the decimal to get to tera. 6 jumps to the left. 6 jumps to the left. So that's 1, 2, and then you'll have to pad it with 4 more zeros, right? 9, 2, 5. Oh boy, this is hard to write with this thick old pen. I got 4 zeros, okay, and then the decimal's going in front of that, right? And you can always just verify, make sure it looks right. So to get to tera to mega, I would go this way by 6. 1, 2, 3, 4, 5, and I would get 92.5, which is correct. Good, 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 good. You can always double check yourself like that. So the old slide the decimal trick. That's a good trick to know. Okay, so now that we're happy with sliding decimals around, the metric system, it turns out, was built for this. It was designed around this whole idea of being able to slide your decimals around. In fact, I've seen it written in some places that if you have a metric unit, you really should use a decimal. Have you ever seen anybody say, like, 1/3 of a liter? Maybe. But it seems like people are more likely to say 333 milliliters. Anyway, we'll get to these units later. We tend to use decimals, and the reason is because the units are set up so that you can convert by sliding decimals. So what's all this stuff here? This stuff, these are our new prefixes, and notice they basically squeeze in here. So between kilo and the 1, between the kilo and the 1, we've inserted 2 more prefixes, hecto and deca, and between the 1 and the milli, we've inserted 2 more prefixes, deci and centi. So it kind of, zooms in between kilo and milli and puts a few more things in there. So this is the new prefixes for today. So let's look at these again. So kilo means 1,000, 10 to the third, which of course is the same as 1,000, and it's abbreviation K. Hecto, H, hecto, H, stands for 10 to the 2, which of course is the same as 100. 10 to the 1 is the same as 10, and that's a deca with the abbreviation DA. That's a special prefix because they ran out of D's. Did they run out of D's? We don't have a capital D stands for anything. What are they doing? I suppose they could have used like a Greek D, which is sort of like this. But they didn't. They just made a DA. Who knows what goes on? Who's in charge of this? I don't know. Anyway, so deca is 10 to the 1, which just means 10. So if you have 10 liters, that would be a decaliter, and so on. If you have 100 liters, that would be a hectoliter. If you have 1,000 liters, that would be a kiloliter, and so on. So the prefixes work the same as the engineering prefixes. It's just, they're squeezed in. So then we have 10 to the minus 1, which is a tenth of a whatever. So if you have 1 volt and you split it into 10 pieces, each of those would be a decivolt. Deci stands for 0.1 or tenth. Maybe that's a good way to say it. Centi is hundredth or 0.01, abbreviation C. And then we're back to the familiar milli. So those are our new prefixes. Okay, so let's play with them just a little bit here on this page. So this says to go from a meter to a centimeter. Well, I'm going to do that same decimal slide stuff. Where's the meter? Well, that's like a base unit, right? So that's like starting here. I want to get to centimeters. Where's that? Over here. Now this time I'm not jumping, 3 decimal places each, just 1 decimal places each, because the powers are only changing by 1. So anyway, I go to the right 2 spots. I got to do that. So that 17, pad it with 2 zeros, is going to be a 1,700. 17 meters is 1,700 centimeters. To get from meters to hectometers, okay, let's erase that again. I'm going from meters, which is a base unit, to a hecto, which is over there. It's over there how far? 1, 2 jumps of the decimal. So I'm going to the left, 2 jumps of the decimal. So the 17 will become a 0.17. Now, if you're a nursing major, you're not supposed to put a 0 in front because they're afraid the decimal will go away and someone will think you meant give this guy 10 grams of drug and kill him. That's not what they meant, right? So they tend not to use zeros in front. I'm not really sure. When I was drafting, you had to put the 0 there. I don't know what they do these days. So you might have to put the 0 there. Ask your boss. Anyway, let's do this one. Hectometers, go to meters. Hectometers, go to meters. So let me erase this. I'm starting at the hecto, and I'm going to the meter, which is a base unit. So to start here and go there, I have to make 2 leaps to the right. So that's what I'm doing with my decimal. So if I make 1 leap to the right, it's an 84. So I have to pad another 0 to make it 840. So I can do 2 jumps. So 8.4 hectometers is 840 meters. And one more. You got this one done? You do this one yourself here. Where are we going? Deci. Where's that? Here. I should erase that. And we're going to, remember the DA is a deca. It's a special one. Deca. So we're going over to here. Start at deci, go over there. Oh, it's 2 to the left. Okay. So it's a 0.434. And I'm going to put the 0 there because it makes me happy. Okay, cool. So that's basically, as far as calculations, if you will, that's the new stuff for today. So it's kind of a brain thing going on here today too. You need to learn these new prefixes, continue using these prefixes because you want to get them memorized, and start using these prefixes so you can get those memorized as well. Now, notice all kinds of units are possible. I could have a kilovolt, hectovolt, decavolt, volt, decivolt, centivolt, millivolt, and all this other stuff. Or just think of like regular metric units. A kiloliter, hectoliter, decaliter, liter, a deciliter, centiliter, milliliter. Do we really use all of those? Not really. So what I want to do on the next page is point out what are the more commonly used weights and measures in this metric system that we use. And also we want to have an idea for what they are. So like a kilogram. What's a kilogram? Well, it's 1,000 grams, right? Kilo means 1,000. But that's not really how I want to define it. I want to say, like in real life, how do you know you've got a kilogram? Have you ever gone to the store and bought like a 2.25 pound of burger? Those little packages of hamburger that come 2.25 pounds? That is almost exactly a kilogram. I think it would be 2.20 would be a perfect kilogram. But anyway, think of those 2.25 pounds of burgers. You say, hey, that's a kilogram. So it takes more pounds to have a kilogram. So if you have your weight in pounds and you convert it to kilograms, that's the fastest way to lose weight because your number will get smaller because it takes 2 pounds, 2+ pounds to make 1 kilogram. So anyway, think of 2.25 pounds of burger, kilogram. Boom. Gram. Think of like a paper clip, the weight of a paper clip, something like that. Milligram. Well, that's kind of hard to imagine. I'm going to say split a paper clip into 1,000 pieces, equal pieces, of course, and take one of them. If you can do that, and if you can actually tell that you've got something in your hand, then that would be what a milligram feels like. Now, milligram is used a lot. You'll see the milligrams all over the place in, like, you know, how many milligrams of fat? Or I guess they use grams of fat, milligrams of this, milligrams of that. If you read like vitamins and stuff. Anyway, milligrams get used a lot. Kilograms for burgers and kilograms for heavier things and so on. So for volumes, liter. Hey, everybody knows what a liter is these days. It's like a liter of pop. Just go buy a liter of pop and go, oh, that's a liter. In fact, I shouldn't even put an approximately equals. I should put a really equals, a liter of pop. Deciliters get used, maybe not that much, but a deciliter would be basically 1/10 of a liter of pop. Now if I scroll back up for a second, notice that if you want to go from liter to deciliter, you would move your decimal, or I'm sorry, not that way. If you wanted to go from deciliter to liter, you would go to the left. So 1 deciliter equals 0.1 liters, which is 1/10. That's what I meant to do, right? It's 1/10 of a liter. Okay, cool. Now a milliliter, yeah, that's like 1,000th of a liter. Would be a good way to, well, 30 milliliters is a medicine cup. How do you spell medicine? I always get this wrong for some reason. Medicine? I don't know. Medicine, a med cup. So 30 milliliters is a medicine cup of NyQuil or whatever you're taking. cc's, exact same thing as a milliliter. The exact same thing. So, for example, a liter has 1,000 milliliters. Not that. way. Okay, so a liter has like 1,000 milliliters. Okay, that's just from the table up above, the chart up above. 1 liter is the same thing as 1,000 cc's. And I mention that because this conversion fact has come in handy for me a lot over the years. A liter is 1,000 cc's. A cc is a milliliter. These are the same. These are exactly the same thing. Now, cc stands for cubic centimeter. The cc is a cubic centimeter. It turns out if you measure out a cube, 1 centimeter on each side of the cube, you will get a volume of, well, 1 cubic centimeter, which will be the same as a milliliter. Now, you might also think in terms of like, what really has a volume of a milliliter. Think of, I think of 1/2 of my pinky tip, which is approximate, of course, and it depends on how big your pinky is too, I suppose. But about half of my pinky tip, roughly, would be a milliliter, which would be a cc. Okay, so what else we got? Kilometers. Kilometers. How big is a kilometer? It's like, and I don't want to say equals, I want to say approximately equals 5/8 of a mile, roughly. It's pretty close. It's about 5/8 of a mile. So if you go, let's see, if you go 5 miles, you would have gone 8 kilometers. So it's a 5-to-8 ratio. A meter is like approximately 39 inches, roughly. So it's a little more than a yardstick, right? 39 inches or so, roughly, 39 point something. Centimeters, oh, you know those, they're on the other side of the ruler. So you got your ruler, and that says 1 inch, and that says 2 inch, and then if you look at the other side, it'll go something like this. This will be almost 5 centimeters. It roughly lines up with 2 inches. I forget if it's a little bigger or a little smaller. I think it's a little bigger, actually. But anyway, 2 inches is about 5 centimeters, very roughly. But it's those things on the other side of the ruler. And then the millimeters are those tiny little things. So you see your centimeters, and then you can see the little, they have they have those little itty bitty lines in between. Those are all the millimeters, which, if you want to be funny about it, you can call it a mini meter. I'm not going to be funny. This is serious stuff. So anyway, that's about what they are. Areas. Oh yeah, I got something interesting to say about areas. A square kilometer, well, you'd have to try to picture, I guess, like 5/8 of a mile on one side by 5/8 of a mile on the other side. It's a square kilometer, so you have to measure 2 dimensions, right? You have to measure a length and a width in order to make a square kilometer. Get to that one in a second. A square meter would be, well, you'd measure 1 meter on this dimension and 1 meter on this dimension. So areas are like different kinds of units, right? They're not meters, they're square meters, they're plates, they're tiles, they're whatever they are, they're that big. And a square centimeter is like tiny, well, I guess it would be the area of my pinky, half a pinky tip. Area, if you just kind of look down at it and something like that. Or you could take, of course, the centimeters off your ruler and just try to form a 1 centimeter by 1 centimeter square like this, and you'd have a square centimeter. Again, areas are separate units. You wouldn't say area in centimeters. That doesn't make sense. You measure a length in centimeters. An area is a square centimeter. So you have to make a square. You have to measure twice. You have to measure this way and that way, across and up, length and width. Anyway, so we'll play more with areas in the next lesson. But I wanted you to kind of start getting the idea of, these things. And then I also wanted to introduce, what's that? That is called I need purple. I'm in a purple thing here today. That is a hectare. And if you're in civil engineering, you're going to use hectares a lot. Well, actually, I don't know if you're going to use hectares a lot in this country. You might. Maybe in Canada or something. It's like acres. It's like the metric kind of acres. It's actually smaller than the acre. I forget. I think it's smaller than. You'll have to check me in the next lecture. I'm pretty sure it's like smaller than an acre. But anyway, a hectare, it's like a unit of area for measuring land, and it measures 100 meters on one side by 100 meters on the other side, which means it's 10,000 square meters. By the way, how many square meters are in a square kilometer? This would be, a kilometer is 1,000 meters, right? So if you have 1,000 meters one way and 1,000 meters the other way, you've got 1,000,000 square meters. So 1,000,000 square meters would be a square kilometer. 10,000 square meters would be a hectare, which is, you know, you don't want to measure your property in square kilometers. You want to use something smaller, so hectares is the thing. And we'll be converting with areas and volumes and stuff in the next lesson. But there, now you know what a hectare is. Is that really all I got to say? Is that really it? Okay, so those are our metric units. Get used to them. Gotta love them. Live them. Love them. Learn them. Live them. Love them. Something like that. And cool. So in the next unit, we're going to start converting units in really fancy ways. So see you there.